Welcome to a new video which is about introduction to derivatives. I am planning to make a series about derivatives and this is the first video of the series, and without further ado let's get started. Here guys we have a definition, and in the definition it says the derivative of the function f of x with respect to x is the function f prime, which is represented like this, whose value at x is f prime, which is defined by using the limit when h goes to 0, f of x plus h minus f of x divided by h, where the limit exists. So in this case we are supposing that limit already exists. And the process of calculating a derivative is also called differentiation. You may hear that term a lot of times when the subject is derivatives. And we have an example. The first example says differentiate y is equal to f of x, which is equal to 2x plus 1, guys. We're going to solve this question by using this formula. Well, actually, this question is a polynomial, and there is a shorter way to find the derivative of this polynomial. But because this is just an introduction, and I just want to show you where the derivative comes from, and because of that, actually, I just want to solve the questions in this video by using this formula that we have. So here we need f of x plus h, which is right here, right? And we already have f of x, which is already given us here. So let me write f of x plus h here. And of course, what we need to do is just we're going to put x plus h instead of x right over here, right? So it's going to be 2 times instead of x, and now I'm going to write x plus h plus 1, and if you distribute this 2 into the parentheses here, then this is going to be equal to 2x plus 2h plus 1, guys. So if you write this, okay, f prime of x limit when h goes to 0, then we have f of x plus h, which is 2x plus 2h, this is 2, plus 1, and then we have minus f of x. Well, if you put minus, okay, instead of this f of x, then you're going to distribute this negative into parentheses, so it's going to be negative 2x minus 1, guys. So it's going to be negative 2x minus 1, and in the denominator we're going to have h, guys. Here we have 2x and we have negative 2x, those are gone. We have plus 1 here, we have negative 1 here, those are gone as well. And the leftover is we have just here 2h, and in the denominator we have h, guys. So this is gonna be equal to limit when h goes to 0, 2h divided by h, guys, and those h values are gone as well, the variables gone, and the leftover is 2, guys. And because there's no any variable with 2 and 2 is alone, so that means we already found the answer, which is 2, guys. So if you differentiate f of x, and then we're gonna have 2 as a result of this operation. And this is our next question, guys. We have differentiate the f of x where it is x plus 1 divided by x, and our formula is here also. So what we're gonna do is we will find out f of x plus h. F of x is already given to us, so f of x plus h is equal to, guys, all we need to do is we're gonna put x plus h instead of x here. So it's gonna be, of course, x plus h plus 1 divided by x plus h, guys. And once you apply this formula, then we're gonna have f of f prime of x, which is equal to limit when h goes to 0, guys. Then we will have, instead of f of x plus h, we will put this function. So we're gonna have x plus h plus 1 divided by x plus h, guys, minus f of x, which is x plus 1 divided by x, and divided by h, guys. As you can see, in the numerator part, we have two fractions and their denominators are different. So we're going to make x plus h, which is this part, and x the same. And in order to do that, we need to multiply the first one by x, and we need to extend the second fraction by x plus h, guys. So this is going to be equal to x times x plus h plus 1 divided by, actually the denominators are the same, so I'm going to extend this, minus x plus 1 times, suppose this is a multiplication, x plus h, okay, divided by x times x plus h divided by h. If you divide the whole term by h, actually, okay, let me write it first. In the next step, I'm going to put this h right over here. In the next step, we're going to have f prime of x, guys. This is equal to, and I need to distribute this x into the parentheses here. And once we do it, then we're going to have a limit when h goes to 0 part. Let me draw a line here. So I'm going to distribute this x into the parentheses, then we're going to have x squared plus xh plus x minus, guys. Now I'm going to multiply those like this, x plus 1 times x plus h. So if you distribute this, x times x, which is x squared, right? And then x times h, because of that minus, it's going to be negative xh. And then 1 times x is x, but it's going to be negative x here. And then the same thing, 1 times h, which is negative h here, guys. And in the denominator part, we're going to have x times x plus h, and also we have h here. That h comes over here, guys. And this is equal to, guys, to save some space, I'm not going to write a limit at the moment. I'll just write the whole term as a fraction. But before that, let me cancel some terms. For example, this x squared goes with this x squared because one of them is positive and the other one is negative. The same thing is here, x times h goes with this negative x times h here. And then we have positive x here, we have negative x here. In the numerator, we're going to have negative h. Okay, let me write again, limit. It looks like I'm going to have enough space. When h goes to 0, in the denominator, I'm going to have h times x plus h, guys. In the numerator, we have just negative h. That h goes with this h. And when x goes to 0, guys, okay, you're going to put here 0 also. So in the numerator, we're going to have negative 1, right? Negative 1 divided by, in the denominator, we're going to have x times x, which is x squared, guys. So the final answer is, in this question, negative 1 divided by x squared, guys. And this is our last question, guys, in this video. And we have find the derivative of y is equal to f of x, which is equal to 1 divided by x at the point x is equal to 2. That means, guys, actually, we are asked to find f prime of 2, guys. So we're going to find what is f prime, which means that the derivative of f of x is equal to what? And then after finding this, we're going to plug 2 in x, then we will get the result. So we will apply again the same formula, and this is equal to what? So we will find what is f prime of x, guys, and this is equal to f of x plus h, which is, guys, 1 divided by x plus h, minus f of x, which is 1 divided by x divided by h, guys. Again, in the numerator part, we have two fractions, and we need to make the denominators same. So let me continue here. F prime of x is equal to, there's h here already. And for the first term, we're gonna multiply this by x, right? So once you do it, then we're gonna have x divided by x times x plus h minus, we're going to multiply the second fraction by x plus h, and once we do it, then we're going to have x plus h here, and the denominator is going to be the same, so x times x plus h here also. And this is equal to, guys, by the way, we forgot to put limit when h goes to 0. Okay, limit when h goes to 0 should be here, and also limit when h goes to 0. Limit when h goes to 0, then we have x here, we have negative x here, so those will be gone, and we're going to have negative h in the numerator, negative h divided by, in the denominator we're going to have x times x plus h, guys, and here also we have h here. In the next step, those h values will be gone, so we're going to have limit when h goes to 0, then negative 1 divided by x times x plus h, guys. And now when h goes to 0, that is 0 also, so this is going to be negative 1 divided by x squared, guys, because x times x is going to be x squared. So this is the derivative of f of x, guys. So f prime of 2 means we need to plug 2 in x, so we're going to have negative 1 divided by 2 squared, which is 4, guys. So the solution of the question is negative 1 divided by 4, guys. If you have any question, guys, related to the questions or anything else, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.